Hi guys, today's video is on Bessel function. Bessel function is a continuation of Bessel equation. Now let's take a look at Bessel function. When you have gamma x plus 1, this is going to give you x, gamma x. This is what you have. So if you have gamma x plus 2, you're going to have x plus 1, x, gamma x. If you have gamma x plus 3, is going to be x plus 2, x plus 1, x, gamma x. Gamma x plus 4, we're going to have x plus 3, x plus 2, x plus 1, x, gamma x. So this, when you have x plus 5, you're going to, if you have gamma x plus 5, so I believe you're going to, you know what you're going to have next. So it is going to be x plus 4, x plus 3, x plus 2, and so on like that. And another thing we need to know, we have an arbitrary constant a naught, which is equal to 1 over 2v gamma v plus 1, which can also be written as 1 over 2v v gamma v. If you check gamma v plus 1, is just like saying gamma x plus 1, which gives us x, gamma x. So definitely this one is going to give us dp gamma v. So that's how we arrive at this answer. Now, like I said, Bessel function is a continuation of Bessel equation. Now we are going to use those values that we obtained for a naught, a2, a4, and a6 from Bessel equation. We're going to turn all those one to Bessel function. So let's go. So we have a naught, a2 to give us minus 1 over 2 raised power 2 v plus 1. That is what we have for a naught. If you check for a2, this is what we have. Sorry, minus a naught. This is what we have. Now, if I now substitute this a naught into this equation, we're going to have minus, we're going to have 1 over 2v v gamma v multiplied by minus 1 over 2 raised power 2 v plus 1, which is going to give us minus 1 all over. Now this 2 raised power v multiplied by 2 raised power 2 is going to give us 2 raised power v plus 2. Now when you multiply v plus 1 v gamma v, if you multiply this and this, we have this. It can be written as x plus 1 x gamma x. Now when you check what you have here, we can see that x plus 2 is one that gives us x plus 1 x gamma x. So which means that this answer here is going to be gamma v plus 2. So this is what we are going to replace it. We now have gamma v plus 2. So this is what we have. This is what we have. Now for the value of a4, we're going to have, so for a4, from the last video, we got a naught over 2 raised power 4 multiplied by 2 in brackets of v plus 1 v plus 2. This is what we obtained from the last video from Bessel equation. Now let's turn it to Bessel function. A naught is 1 over 2v v gamma v multiplied by 1 over, so we have 2 raised power 4 multiplied by 2 v plus 1 v plus 2. So which is going to give us 1 multiplied by 1, we have 1. 2v multiplied by this, we have 2v plus 4. Now multiply by 2. It to be multiplied by 2. So you're going to let's write it as 2 factorial. So since 2 factorial is the same thing as 2, so we're going to write it that way. Now for this one, we have v, v plus 1, v plus 2, and we have v gamma v. We can see that it is the same thing as this: x plus 2, x plus 1, x gamma x. It's the same thing as saying x plus 2, x plus 1, x gamma x, which gives us gamma x plus 3. So here now we're going to replace it by gamma b plus 3. So this is what we're going to have. Now let's go to the last one, which is a6. We obtain the value of a6 to be minus a naught over 2 raised power 6, 3 factorial, we have 3 factorial, 2 raised power 6, 3 factorial, v plus 1, v plus 2, v plus 3. That's what we have. So it is going to be, if we substitute a naught, we have 1 over 2v v gamma v multiplied by minus 1 over 2 raised power 6, 3 factorial, v plus 1, v plus 2, v plus 3. So if we do this, we're going to have minus this multiplied by, so we have 2v plus 6, then 3 factorial gamma. You can tell me the next one. Okay, so it's going to be v plus 4. You can see that they are following a series. A naught is gamma v plus 1, a2 is gamma v plus 2, a4 is gamma v plus 3, and a6 is gamma v plus 4. So let's put in our answer back to the equation. So we have y equal to x raised power c in bracket of a naught plus a2 x2 plus a4 x raised power 4 plus a6 x raised power 6. So y equal to x raised power v. So we have 1 over 2v gamma v plus 1 minus our a2 is minus 1 over, so we have x2 x raised power 2 over 2v plus 2, 1 factorial gamma v plus 2 plus x raised power 4 2 raised power v plus 4, 2 factorial gamma v plus 3 minus the next one, which is x raised power 6. Now let's factorize. We have x raised power v. You can see that here we can factorize 2 raised power v out. When you have 2 raised power v plus 2, I can write it as 2 raised power v times 2 raised power 2. multiplied by 2 raised to power 2. Thereby, I can take out these 2 raised to power v, and it will be 2 raised to x raised to power v over 2 raised to power v. So we can rewrite it as all raised to power v. Now, we're going to have 1 over gamma v plus 1 minus x squared. This one is going to remain 2 raised to power 2, 1 factorial gamma v plus 2 plus x raised to power 4 over 2 raised to power 4, 2 factorial v plus 3 minus the next one. And all this one is equal to jv function x. All this one is equal to jv function x. Now, I'm going to show you the meaning of jv function x later on. Now, the next one is when c equal to minus v. When you have c2 equals to minus v, the a naught here is going to be 1 over 2 minus v gamma 1 minus v. So which we can also write it as 2 minus v gamma v. We can write it like that. Now, our a naught, our a2 there was a naught over 2 raised to power 2v minus 1. This was the a naught that we obtained when we when we use Bessel equation. This was the a naught we obtained. Now, for this one now, because our va is 1 minus v, so let's multiply both sides to change what you're having. So if you multiply both sides by my negative, so you're going to have 2, then we have 1 minus v. We want to change this to this form so that they can be equal. So that's why we multiply this by minus, this by minus. So that's why we have this. Okay, now we move on. Now, this is going to be the a naught, so which is going to have 1. What is a naught? A naught is 2 minus v gamma v multiplied by minus 1 over 2 raised to power 2, 1 minus v. So which is going to be minus 1 over 2 raised to power minus v plus 2 gamma 2 minus v. So this is what we're going to have. And for a4, a4, by the time you substitute this a2 into a4, so it's going to be positive. So you're going to have 8 naught over 2 raised to power 4 multiplied by 2, then we have v minus 1, v minus 2. So equal to 1 over 2 raised to power minus v gamma v multiplied by 1 over 2 raised to power 4 multiplied by 2 v, sorry, that will be 1 minus v, rather 1 minus v, and this one will be 2 minus v, this one will be 2 minus v. So we're going to have 1 minus v, 2 minus v, so which is equivalent to 1 over 2 minus v plus 4. Now write this as 2 factorial. So we have v 1 minus v, 2 minus v, then multiplied by this v gamma v, so which is going to give us 1 over 2 minus v plus 4, 2 factorial. All this we can see that is written as gamma 3 minus v. For a6, we have a6 to equal to minus a naught over 2 raised to power 6 3 factorial so by 3, so this one is 1 minus v 2 minus v 3 minus v. Now by the time you substitute a naught into it, you're going to have minus a naught minus 1 over, this is minus 1 over 2 raised to power 6 minus v plus 6 minus v plus 6 3 factorial, then we have gamma 4 minus v. So that is what we are going to have. Now writing it in back to the formula, so y equals to x raised to power c in bracket of a naught plus a2 x squared plus a4 x raised to power 4 plus a6 x raised to power 6, which we are going to have x raised to power minus v now in bracket of 1 over 2 minus v gamma 1 minus v minus 1 over x squared over 2 minus v plus 2 gamma 2 minus v plus 1 over 2 minus v plus 4 to gamma 3 minus v minus the next one, this is x raised to power 4. So when we factorize it out, it will be x raised to power x over 2 all raised to power minus v 1 over gamma this minus x squared over 2 raised to power 2 1 factorial, let's write 1 factorial gamma 2 minus v plus x raised to power 4 over 2 raised to power 4, then we have 2 factorial 3 minus v minus the next one. So this is going to be what is j b function x? J b function is equals to x over 2 raised to power v summation k equals to 0 to infinity, so whereby we have minus 1 all raised to power k x raised to power 2k over 2 raised to power k factorial gamma k plus v plus 1. When j minus v function x equals to x raised to power x over 2 minus v summation k2 equals to 0 infinity, so we have minus k x raised to power 2k over 2k k function k factorial, then this one will be k minus v plus 1 k minus v plus 1. Now whereby k can equals to 0 1 2 3 etc. Now let's take k for, let's check whether we are correct. When k equals to 0, what are you going to have? So we have x raised to power, let's substitute to this first equation v, so it's going to be, now if I put 0 here, so that will be minus k just for 0 x raised to power 2 multiplied by 0 over 2 raised, now this is, sorry, this is 2, or this one is 2k, we have 2k we have 2k is 2k. So whereby that 2 multiplied by 0 is 0 factorial gamma 0 plus b plus 1 plus 1 raised power 1. If you put in 1, x raised power 2 multiplied by 1 over 2 raised power 2 multiplied by 1 factorial gamma 1 plus z plus 1. So we're going to have x over 2b, and this one is 1. Anything raised power 0 is 1, this one is also 1. So we have 1 here over, we have this raised power 0, and 2 raised power 0 is 1. 1 factor is also 1. So it's going to remain gamma v plus 1. Now this one is 1 minus 1 raised to power 1 is minus. So that's why we have minus here. Then x raised to power 2 over 2 raised to power 2, 1 factorial. So we have b plus 2. So you can see that it is the same thing as what we have here. Let's check. The first one we had when b. So you can see this is what we have. This what we have here is the same thing as this one, minus this is the same thing as this one. When you do the next one, you're going to get this one. Likewise, when you substitute it to this equation 2, for this equation when it is minus v, and you put in your k to this, you're going to arrive at the same answer as this one, as this. We're going to arrive at this one. So that's why we represent, we're going to represent our answer. It will be y equals to u plus b, whereby our u is it will now be j b x plus, because that's the all answer that we obtained, plus minus. So we're going to add this now to differentiate it. Now just say this is a, this is b. Now this is going to be our final answer. Thank you for watching the video. Please subscribe if it's your first time. Please subscribe.